Welcome to Barron Talks. I'm Dr. Ralph Ford, Chancellor of Penn State Barron. Today my guest is Dr. Darren Williams, Professor of Astronomy and Astrophysics. Welcome to the show, Darren.
Thank you. Thank you.
Appreciate you joining. I'm going to run through your bio and then we'll get to the questions.
Sure.
Darren, you've worked here for a number of years. You're a Professor of Astronomy and Astrophysics, as I said, and the undergraduate coordinator for our physics program at Barron. You hold a PhD in astronomy and astrophysics from Penn State University and a bachelor in physics from the University of Pittsburgh. You've received funding for your research from prestigious sources such as NASA and the National Science Foundation. I know you've been published in Nature.
Yes.
That's a big deal for our listening audience.
Yes.
You were a recipient of the Geological Society of America's Dwornik Award, which supports planetary science. And you coordinate a very popular program here on campus, and I'm always impressed when I sit in on them, how many people are there and how engaging they are. That is the Astronomy Open House Nights here on campus, where we often go out to the Mahalso Observatory. So anyways, again, welcome to the show, Darren.
Yeah, it's great to be here.
Tell us a bit about your path to Barron. How did you end up here?
Sure. So when I sit with students and I ask them what they want to do in 10, 15 years, a lot of them haven't thought about that. And that surprises me because my path started when I was 8 years old. I saw Carl Sagan on TV. I went to planetarium shows. I went to museums. I watched everything I could and read everything I could about astronomy. I knew I wanted to be an astronomer. I didn't know what I was going to spend my days doing, but I knew I wanted to do something with astronomy. And I knew that all throughout high school and into college. And then when I was in graduate school, I realized that I enjoyed teaching, and I really wanted to share what I was learning and what I was researching. So Barron actually was the perfect fit for me 23 years ago.
Yeah, and you studied obviously at University Park, and then you made the transition here to Barron.
Immediately, yeah. It was a storybook ending to a graduate career. So I interviewed here, and then 2 weeks later, I defended my thesis at University Park, had a big party that evening, and then the next day was offered the position here. And so there were I was celebrating for a week, multiple things.
That's a good path. You packed up your bags and you moved up here.
That's right.
And so anyways, astronomy. You teach both astronomy and physics. Right. People are probably pretty intimidated when they meet you and say, "Well, that's some pretty far out stuff, difficult mathematics and theory behind it." But why don't you tell us? What is it that made you interested in that, and what should students know who are thinking about studying it?
Well, physics, if somebody asked me what I do at the grocery store in Walmart or whatever, saying physics, that's the end of the conversation right there, because people are intimidated by that word. They know it's complicated. But if I say astronomy, it's just the opposite. Then that starts a whole new conversation, a series of questions. I've always wondered about the universe and the Big Bang and black holes and stuff. Physics, as we know, is the root of the classic sciences. And so the biologists will be thrilled to hear me say that they're at the top of the classic science hierarchy. But biology is just applied chemistry. Mm-hmm. And chemistry, being the study of mass and energy and the interactions of molecules and atoms, is just applied physics. And physics is applied mathematics. So the mathematicians are really supporting all of us. But astronomy is just applied physics. And it's a branch of physics. It's, dealing with questions about our place in the universe, how big the universe is, what's in the universe, where we come from. Are there other people, organisms like us elsewhere?
Yeah. Well, and we'll get more deeply into some of those questions. But as you said, physics, my background is engineering, sure. And I say I'm really nothing but an applied physicist right. and mathematician, and that is the truth of it. So if a student is thinking about a career in physics or astronomy, What advice do you have for them if they're a young kid or they're a high school student thinking about it? What should they do?
Well, I always advise them to first I ask them, are you interested in, or good at math? Because there's a lot of math in physics. And if they're a little bit shaky in math, they can still do physics, but maybe as a science writer or a web designer, or they could work at museums, planetariums, stuff like that. So there is still a pathway if you're not a mathematically minded person. But for those who aspire to do physics as a career, astronomy as a career, take as much math as you can in a hurry at the undergraduate level, and take as much physics as well.
You possibly can.
As you
And
can.
don't be intimidated. Don't say, I don't like math, or
Right.
I'm not a math person.
Right.
Those things drive, everybody can get involved in these things.
Everybody, yeah. So in my intro classes, there's very little math. There's relatively little math in the intro astronomy classes that I teach. I show them that there's a lot to be understood and that can be shared without mathematical ideas.
Well, as you said earlier, when you tell people you study astronomy and astrophysics, they can relate to that. Everyone loves, we see it in our popular culture, we love science fiction. I was a huge Star Trek fan. That's what I grew up on. There's always been this public fascination with space travel, exploration. What do you think drives that?
Yeah, people are fundamentally curious about the human placement in the cosmos and what is the universe and what's in it. Also, what are we? Are we just balls of atoms and molecules? And how do we fit into the grand scheme of things? These fundamental questions for humans, they drive the curiosity, and they cause people to want to enroll in my classes. And then I get them in there, and what I do is I find ways to expose them to complicated things that they wouldn't otherwise choose to be exposed to or choose to learn. But I do it in a way that relates to their lives. For example, if you start out on day one talking about spectra in astronomy, astronomers know a lot about the universe based on gathering light and analyzing spectra. No one knows what that word is or what it means, but everybody knows what a rainbow is.
Mm-hmm.
Or a telescope. Telescopes look big and intimidating, but if you explain it as a bucket that you're capturing a rain of light from the sky, things like that, they can relate to. So there are ways of explaining and understanding complicated things, but simply. And in my classes, that's what I aspire to do.
Well, I think that's what a great teacher does, right? You see all this complicated math, but usually there's a very simple, maybe not so simple, but there's a fundamental underlying principle that people can grasp.
Right. I've always said if I can't explain it to my parents, it might not be worth explaining.
I think there was a statement I've seen when I was in grad school that nothing, it was actually by a physicist trying to advise graduate students on how to present, but nothing should be explained in the way that an intelligent 10-year-old couldn't understand. I think was the quote that I remember, and it stuck with me for a long time. Well, one thing that interests everybody is the idea of extraterrestrial life. It's, we see it again in the movies. So instead of me trying to ask you the question, do you think there is? We can get to that, but what are the conditions that are necessary? What makes us think that it's even possible that there is extraterrestrial life?
Well, one of the sources of confidence, or maybe overconfidence in the existence of extraterrestrial life, is that we now know a lot about the Earth, how old it is, what the early conditions on the planet were like. And it looks like as soon as the Earth stopped being hit by large asteroids and comets 4 billion years ago, as soon as the surface cooled off and we developed an atmosphere, there are signs, there's fossil evidence for microbial life on our planet. And so for me and for many others contemplating the existence of life elsewhere, this just means that that as soon as conditions become suitable, then life is almost inevitable. In other words, liquid water might be the key ingredient, which can facilitate biochemical processes. We don't know exactly how life on Earth originated. Perhaps we originated, and here's a strange possibility, but perhaps we originated on Venus or Mars and were launched. The microbes, the original microbes, could have been launched off of Venus and Mars by asteroids and comets, traveled through space for a while, and then fell onto the Earth, and then we started from there. The same thing could have been true of the Moon. The Moon could have supported life as we know it. There are planets. We're now aware of over 4,000 planets around other stars, and a fraction of them are in what's called the habitable zone, meaning if you had water on the planet, it would be in liquid form, and we don't know that the planets that we're looking at have atmospheres, but we suspect that everything the size of the Earth around another star is going to resemble the Earth in that regard. So if it has an atmosphere and it has oceans of liquid water, then there's at least the environment suitable for simple biochemistry. Now, whether the life forms that we're imagining are life forms that we can talk to communicate with,
Right.
That's still an open question. But
you're assuming that there's water, it's carbon based, there's an atmosphere.
water, yeah, similar conditions, similar elements, and the physics and chemistry are the same.
And anything outside of that would be pure speculation as to
Sure.
what another type of life form might be and how it might have evolved.
Right. And we can only hope or guess at what the outcomes are.
Well, last year here on campus, we had a speaker who you hosted and were instrumental in bringing here, Dr. Avi Loeb. He is a Harvard professor. He is I think he's the department chair of their physics program.
He is. He's the chair of a lot of things at Harvard. It's amazing.
But he's gotten a lot of press for saying that he believes there's some objects moving in our solar system that may hint that there's extraterrestrial life. Right. What's going on there?
Right. So when he was here, he spoke about an object which we call Oumuamua, which means messenger in Hawaiian. The object was discovered and observed first off by the telescopes in Hawaii. So that's the origin of the strange name. Anyway, this object, it looked like, when they detected it, it looked like it was flying away from the sun, moving away from the sun. And they could measure the speed. And we know by applying the laws of physics that anything that's bound to the sun, that's not leaving the sun permanently, will travel below a certain velocity. This thing was traveling faster than that minimum speed, the expected speed. So that indicated that it was a visitor, that it had come from elsewhere, that it had zoomed through the solar system at a speed greater than we would expect by applying the laws of physics to known objects in the solar system, asteroids, comets, planets, moons, etc. This thing was flying away from the sun at a speed that was faster than we expected. So the astronomical community, specifically Avi Loeb and colleagues and others now, there are lots of people who are showing interest in explaining Oumuamua. Loeb, he and others have hypothesized that this thing is being pushed by sunlight. And it's a strange concept. If people have never thought about this, if you put a sail, a fabric in space, and just have it at a certain distance away from the sun, the light from the sun will literally push it away. We call it a solar sail.
Solar sails, right? Yeah.
And so this object is very strangely shaped, and they couldn't take a picture of it, so they don't know exactly what it looks like. But it's brighter than usual. We know it rotates really fast, and also that it's that if it's flat in one and facing the sun occasionally, then the sun will push it away and accelerate it away at a speed faster than what's called the escape velocity. And so Loeb, he just published all of his findings in a book called Extraterrestrial. I just read it a few weeks ago, and he describes nicely how this object is, according to him, likely to be a remnant of an alien technology, and that maybe this solar sail was fabricated by somebody else and sent out into the galaxy, and just by chance it intersected our solar system, fell into the solar system, didn't fall into the sun, but whizzed by the sun really fast, and was on its way out when we saw it.
Wow.
Back in 2017. But there are now, today in 2021, there are competing hypotheses. The velocity, the strange velocity that this thing could have, could be a result of material being thrown off the small object, things smaller than a city. And so it's extremely tiny, and it's difficult to see. We can't see it even today. It's too far away to see. But you could accelerate the thing by sending gas out one side, and so another team from San Diego or Arizona, they have calculated that if the thing was just a chunk of ice, then as it got close to the sun, then those ices would evaporate, and
gases could make it move faster.
and be ejected like a rocket out one side, which would propel it in the other direction at a speed faster than the escape speed. If that were to be the case, then the object would still have to have originated outside the solar system, and it would have had to have been made of frozen nitrogen ice. They sampled, on paper, they sampled different kinds of ices, and only at those temperatures and distances from the sun would nitrogen ice provide the necessary acceleration. So that paper came out in Nature just a month or two ago. Avi Loeb visited in November of 2019. So this is a developing topic, and the scientific community is just left to ask, well, which explanation is it? Is it alien technology in the form of a solar sail, or is it some chunk of nitrogen ice? No one knows.
Well, like many questions in science, it's not settled, and it may take some time. But just one more question on this subject. Sure. What is your opinion?
Well,
and if you don't have one, that's fine.
I don't have one, and I don't have a preference either. It would be really interesting if this were alien technology, but I don't push either as being more viable than another. Based on my scientific opinion, is that it could be either. And if there's any tension in the community, which I'm now becoming aware of between the different arguments, then that's just interpersonal tension. It shouldn't be there shouldn't be scientific.
It should be just debate on the facts and competing
theories,
and
debate the facts, debate the numbers.
So, Darren, using the Kepler Space Telescope, astronomers have identified some Earth-sized planets, at least in theory, where life might exist. So, what's the next step, though, in studying them?
Yeah, so we now, I think the last number, every day I have to look, the number keeps going up. It's now 4,000 something. It might be close to 5 now. And most of those planets have been discovered by Kepler. What Kepler was, a telescope smaller than the Hubble Space Telescope, but it is a space telescope, and it's in orbit around the sun. It's not in orbit around the Earth. It's in free fall as it moves around the sun, just like the some of our other space observatories. Anyway, it's about 1 meter across. So if you can imagine a chunk of glass, 1 meter across at the bottom of a big tube. And the thing was, when it was launched about 15 years ago, it was pointed in the direction of Cygnus, which is toward the galactic plane. And that's where, for a region of sky, you get the highest density of stars. And so it was focused on that one region, over 100,000 stars in the one region. And then it just watched, and it used gyroscopes to hold its direction and to monitor those 100,000 stars for a period of a few years, and they were looking for slight dips in the brightness of the stars. Now, stars do brighten and dim sometimes periodically for other reasons than to have planets. But if you had a Mercury-Venus situation where you could have a planet move in front of the face of the star, so that the orbits were just in line with the observatory, then if you have a situation where everything's in line, the planet's in front of the star, there's a small drop in brightness of the star. Now, as soon as they see one, that's not a guarantee that you have a planet. What they do is they then look, they say that's a candidate of interest, and they look at that star again and keep monitoring it, and then they watch for more dips. And as soon as they get two, then they say, well, maybe, okay, let's watch for a third. And then if they see a third, then that's a confirmation that there's something in orbit around that star. And the size of the dip, the amount of drop of star brightness, that tells us how big the planets are.
Wow.
There are other observatories now. Kepler has been up there for a while, and its gyroscopes are failing. There are other observatories, the Gaia spacecraft, for example, which are now able to also look for what are called transits, the passage of a planet in front of a star. So the follow-up observations, once we know that these planets exist, Kepler has listed their masses and their properties for us, then we can look back at the star and watch very carefully when they do pass in front of the star or even behind. We can look for changes in the wavelengths or the frequencies of light that we collect. And if the planet moves behind the star, then the planet's light that we saw when it was in front is no longer visible. So we can watch for changes in the rainbow of colors of the star. And when the planet's in front, it'll look a little bit different than when the planet is behind. And that tells us a little bit about the light that's coming from the planet, which can give us indication whether it has an atmosphere, and also what its what its type is, whether it's a gaseous world or whether it's a solid world.
Now, of these 4,000, I have to ask, what's the closest one? I mean, what sort
the
of distance?
Closest one. There is a star system, and most everyone has heard of this star system, the Alpha Centauri star system. That's the closest star system. Many people don't know, though.
You hear it in sci-fi shows all the time.
Exactly.
Yeah,
It's 4 light years away, which means if you travel at the speed of light, it would take 4 years to get there. But it's the closest system. What I mean by system is there are 2 sun-like stars in orbit around each other, Alpha Centauri A and Alpha Centauri B. And then there's a third star called Proxima Centauri. And Proxima, as you can guess, is the closest of the 3.
Wow.
And that was just a few years ago, 3 or 4 years ago now, they found a planet that is transiting that star. So we know that there's a planet. Not only that, but that planet is in or close to the habitable zone around that star.
Wow.
So within 4 light years away, which is right next door. It seems like a long distance. A light year is...
No, I thought you were going to say 1,000 light years away.
6 trillion miles is a light year, so it's a ridiculous distance, but it's right next door.
Well, let's move a little closer to home.
Sure.
You know, NASA is focused on Mars, and in February, the NASA rover Perseverance landed there.
Right.
And it launched a small helicopter, and it proved that flight is possible. You know, talk about the significance of all we're doing on Mars right now.
It's really exciting, and for those of us who are impatient about space exploration, this is at long last what everybody wanted to do. We wanted to put a drone on Mars. It has an atmosphere, a very thin one, but it has a thick enough atmosphere so that you can spin your drone blades really fast and have it fly around. So we're getting used to, almost shamefully bored with the images that get sent back. They all look the same. It's always a flat desert plain with boulders and stuff. We're getting used to it. Frankly, we see more in the movies, like in The Martian. We want to go to the canyons. We want to go to the craters. We want to see strange exotic places. We want to go to the poles and do exotic things. So this new helicopter, the drone, Ingenuity, is now carrying out some of this and satisfying those of us who are getting tired of the
same old.
Same old. So it's a good step forward, and the helicopter has done beautifully. The last I heard, they had 5 successful send-offs and landings, and it's still working. And they didn't. That was beyond expectations.
Well, that's amazing. I mean, I can remember when the first rover went, and what a
Sure.
what an accomplishment that was. In fact, I
Sure.
don't want to go too far back, but we had some of the people who were involved in the development speak on campus, and it was fascinating back, maybe 2 decades ago.
Yeah.
But, NASA wants to, the goal is to send a crewed mission to Mars. I mean, how likely is that going to be in our lifetimes?
In our lifetimes, that's the question. How long will we live, for one, and two, how rapidly will we get there? But I think, within 100, 200 years, we'll definitely be there. I don't know. Mm-hmm. I can't predict 10 or 20 years or so. But what I'm seeing in the news is the public infatuation with going into space and going back to the moon, and other governments, not just ours, are interested in going out, occupying different places in the solar system. So that's for a future in space. That's a good sign. But the public enthusiasm for space is a significant driver, and also there's a lot of money now being funneled, private money being funneled in this direction. SpaceX, for example, but there's also now a spaceport that has been created in New Mexico, I think, where people can reserve their seats aboard a flight into orbit. So that'll become commonplace, and we're maybe within our lifespan, we're going to have to ask the question, well, it will be affordable for you and I to choose
who gets to go into space.
Do you really want to go? And I'm not sure I do. I'm scared of heights, so I think the vertigo or the sense of zero, the negative senses of zero gravity might get me. But maybe they'll train young kids in the future to just be used to those kinds of things.
Well, you made the point as well that SpaceX, Blue Origin, all these companies are working with NASA now, so the whole model has become different. You've got stars out there, frankly. Elon Musk is, clearly driving a lot of interest. He's now on Saturday Night Live
talking about space exploration.
Exactly. And I didn't watch much of it, but I saw a little bit. He was a little more stilted than I thought, actually, but he seemed to be able to laugh at himself.
Sure.
NASA is partnering now with the private sector. You see SpaceX, you see Blue Origin. How important is it? How necessary is it for that partnership to be there?
Well, it depends on how fast we want to move forward. There's a nervousness, there's a hesitancy with NASA because it's taxpayer dollars. They want to be very careful not to have another Challenger or Columbia disaster. Although there's going to be disasters. Fortunately for SpaceX and the private industry, there haven't been any loss of life, but there will be.
But they've had rockets fail, though,
and they have had rockets fail and explode on the pad. And so when I see those, and the public sees those explosions, they say, "Oh, well, it's going to be years before they recover." But not with SpaceX. They apparently have a bottomless pit of resources and people and money, and within days they've sent a new rocket. Okay, that one exploded. Let's try again. So I think that rapidity and determination is what's going to get us to Mars and the moon. NASA, they'll be part of it, but they move more slowly and conservatively.
But they still provide the real science behind it that's necessary, though.
They do.
And without that fundamental investment and
there's
research and
governmental
development,
support for going into space, and that will drive things also.
Well, we're getting close to the end of our time. Sure. So, is there anything that you particularly would like to add? Anything we've missed, or?
Well, I just want to reemphasize that how important a scientific awareness is for our general audience. Not only for the future of space exploration and the discovery of planets around other stars, but just to become aware of the planet that we belong to and that we share, and that we can make a difference here on our own planet, and how we care for it, and how we correct for and accommodate things like climate change and moving forward in the future as one. Because as Carl Sagan put it, from the vantage point of a spacecraft on the outer edge of the solar system, looking back, we live on a dot, and that dot is everything. It's our source of food and enjoyment. It's where we live out our lives, and so we need to take care of that dot. So I'll echo Sagan's words from a long time ago.
That's a great message. And anyone who's interested in learning more, they can come to our astronomy open house nights. We have this beautiful planetarium here on campus as well.
Sure.
And they can come to our website and find out more. Right. So, well, thank you. It's been a great pleasure having you here today, Darren.
My pleasure.
Appreciate it. My guest today has been Dr. Darren Williams. You've been listening to Barron Talks. I am Chancellor Ralph Ford. Thank you, Darren.